Hello everybody, welcome back to the innovation series. In this video today, I want to show you how you can use custom client functions to create reusable dynamic object mapping. And this has already been released, so you're welcome to use this in production. So the setup is generally something along the lines of this. You've got maybe two customers or two partners, and these are special partners, so you want to be able to cater to their interfaces. And they've got some system that generates some message, some event that is going to be sent, traditionally as a webhook, that you need to handle and process into a normalized schema for your system, your backend application, etc. And the idea here is that, hey, can we cater to multiple customers to allow them to just publish what they have to speed up the integration process so that we're not asking them to have to build some middleware or conform to our API specification. The idea is that we can just tell them, hey, send us what you got and we'll deal with it. And we can make that process of dealing with it so lightweight that it makes sense from a business perspective to do that. So in today's demo, we'll have two webhook handlers coming in, and they're going to be sharing a common server function. Now, these could be separate server functions, one per customer, if there's orchestration logic that's unique. But in our example, let's just say that the mapping is the only thing that needs to be addressed, that everything else is the same between customers. So that's hypothetical, but I think perfectly valid. And then we'll use a client function in this server function here to basically do the transformation. But note that this client function has value beyond just this one server function or this one use case. So the idea is, can we write a mapping function that's agnostic of the object, that basically takes a mapping JSON file and uses that mapping file to perform a transformation without even knowing what object it's dealing with. And then the idea is that beyond that, there's more logic, and I won't be showing any of that today. It obviously depends on the integration. The last thing I'd like to note is there's different ways to build this. You can build it so it's multi-tenant, but kind of aware of the tenants. What I've done today just makes it easier to kind of see and understand. But you could also build this where the different webhook handlers, as they invoke the server function, they pass in different poly keys. And so they actually execute in context of different environments, which means that they're like totally partitioned and totally segmented, where you couldn't even potentially corrupt the data if you tried. So I won't get into that today. It's a little bit more advanced. I'd like to just showcase the concept of dynamic object mapping. And like I said, the real value is that you can expose unique APIs to customers using one common integration to back them. The major innovations we'll see today is Vari being used to access those JSON maps. So having an easy place to keep and maintain those JSON maps. And then also reusable custom client functions, which performs the agnostic mapping. So there's obviously logic inside that custom function, which you have to write, and that's what I'll show you today. But the container that holds that logic, that makes it easy to use within different server functions and makes it generally available for use, that's the real value add of Poly. And our vision here is that soon enough, these Vari JSON maps will have a UI where they could be mapped. And so you can manage these, either your operations team or maybe even your direct end customers could manage the maps, and those maps take immediate effect. So you'd have a real-time ability to maintain the mappings. One last note I'll point is that these mapping files could also be used by different functions. For example, maybe the function that does a query to an external system is dependent, that query is dependent on what data the mapping file shows it needs. So there's more life to these JSON maps than just transformation, but that's what I'll showcase today. So I'll see you in VS Code, where I'll walk you through the client function, and then we'll go ahead and run it and see it behave differently for two incoming events that are different models, but that resolve down to the same underlying model. So this is the function that's used to do the generic mapping. And I used AI to generate this function. It's a little bit hard to read, to be honest. Like this, even this programming is above me, but I've gone ahead and tested it and made sure it works as expected. If you're a developer familiar with TypeScript, you'll probably have no trouble reading this, but it is a little bit advanced and sophisticated. So I do want to point out that most likely this is built by a developer who really understands what they're doing, but they encapsulate it in a reusable way so that developers building integrations who might not be so advanced with programming languages to be able to build such functions can just easily use them. And the beauty of this function is that once you get it right once, you can use it across any number of integrations regardless of what object they're dealing with. So there's a huge reusability factor to getting this function right. A couple of qualities about this function. I wrote it so that it's totally agnostic of the object model and so that you can actually tell it what type you want the result object to be. And I'll showcase that when I show you the maps in just a second. But at a very high level, it's a function that takes in a tenant ID and a source object of some agnostic structure. And then it basically goes ahead and returns another object of an agnostic structure. And that mapping file tells it what it's going to receive and what it's going to output, what it should output. We load those mapping files using Vari, so we obtain it. And then we structured our Vari entries to have one per tenant. And this is what I meant earlier by the fact that this function is tenant aware, where it works off a tenant ID. You can structure this so that it actually just runs off the key, where you don't even have to provide it a tenant ID, but that's kind of one order more of complexity, so I just wanted to avoid that for today's demo. But just know that that's possible too. And then what we do is basically declare an empty object that we're going to be populating. We iterate through the attributes, and we go ahead and use the information from the mapping file to basically both assign a type and map the value for that new object. So we kind of construct the object as we go. Then we basically have a different switch statement to handle numbers and strings. So you'll probably have to evolve this to handle all the data types you might encounter. So we might need one for a Boolean, one for an object, etc. And you might even need to have kind of this function iterate into an object. So this might be just kind of a simpler version of what this function might be. And then lastly, if for some reason we can't find a value with that value, we set it to undefined. We actually do that here. And then basically, we go ahead and return the object here. So if it's not undefined, we set it, and then we basically populate this object, and then we return the object here. So now let me go ahead and show you the two mapping files, and then we'll go ahead and execute these functions, and we'll see them working. So here's the first mapping file inside Vari, and it basically, you'll see for the value, it just has this structure where it says, hey, I want my attribute to be called name. I want you to pull it from custom attribute at 1, and I want you to assign it as a string. And so that's basically a little, again, you have flexibility in structuring this however you want. This is just what my design entailed. And then the second object here is going to have a same structure. I still want it to normalize into name and ID, except here I want you to pull it from my custom attribute foo and my custom attribute bar, and this one I want it to be a number. And I'll show you how to change this. I just wanted to delineate the fact that you have kind of full control over it with this design. The way we'll invoke these is we'll have two webhook handlers, one representing the first customer with custom attribute 1, custom attribute 2, and another one representing the second customer attribute, or second customer, sorry, with my custom attribute foo and my custom attribute bar. So the idea is, again, we're getting two totally different looking objects, but we're going to normalize them to the same schema. Generally, this would run on a server function, but today I'm actually just going to run it locally. So I'll basically have these two webhook handlers receive the events, and then I'll go ahead and invoke that same mapping objects function, the custom function I just showed you a little bit ago, and then I'll basically print the results. So let's go ahead and fire up this process. And we can see we're listening for events. So let's go off and fire off the first event. So here we are. We'll go ahead and do foo and 222. And that one's been received. And then we'll go ahead and sequentially fire off the second event that has a totally different attribute names. And that one's been received. So let's go take a look at the results in VS Code. So we can see that they've both been normalized to name and ID, except remember, one of them I said I want the ID as a string and the other one I want as a number. That's unrealistic. You probably don't want that. I just wanted to showcase you have that full control. So lastly, let's go ahead and just change this ID from a string to a number, and we'll see it show up real time. So to do that, we'll just go update the variable from being a type string for custom attribute 2 to being a number. We'll go ahead and patch it. And we could see that that's been patched here. So without even restarting my process, let's go ahead and fire this one off again. And we should see that they both show up as numbers this time. So we'll go ahead and hit send. And so even though one came in as a string and the other one comes in as an ID, they should be normalized to numbers. And this time around, we could see that the 222 came in as a number and the 123 came in as a number. I didn't have to change my function. I didn't have to redeploy my server function, the integration. I just changed the mapping file and it started treating it as a different type. So with that, I hope this made sense in how much power you can have through those mapping files to represent the logic of the mapping. And then you can write generic functions which are super reusable to be able to serve many different integrations that basically do the mapping based on those files to avoid having kind of custom mapping logic, or even worse, to have kind of hard-coded mapping logic within the integration itself. So with that, thank you very much and have a great day.